In our experiment, we take lead nitrate, which in 1 molecule of lead nitrate looks like this, with the lead being the red and the nitrate being this. And in lead nitrate, we have 2 moles of nitrate to every 1 mole of lead. That's why there's 2 nitrates in 1 lead. Now we're going to mix the lead nitrate with potassium iodide. And a molecule of potassium iodide looks like this, with the blue being the potassium and the white being the iodide. So before we can mix the molecules together, we first have to dissolve them so that there are a bunch of ions floating around in the solution and not molecules. So in order to dissolve it, we're going to mix some H2O, water, with our molecule, potassium iodide. So here it goes. Pour in the H2O, mix it up, and see what we have. So here we have a bunch of potassium ions with a positive charge, which are going to form ion dipole bonds with the negative charge O's in the H2O. And here we have some iodides with a negative charge, which are going to form ion dipole bonds with the positive part in the H2O, the H. So as these ions move about the solution, because they're charged, they're going to be conductive and can create an electrical current. Now the reason why the potassium and the iodide break apart is because the attractive force between the H2O and the potassium iodide is stronger than the attractive force between the ionic bond between the potassium and the iodide. Thus, the 2 ions are pulled apart and the ion dipole bonds are formed. Now let's see what happens when you mix water, H2O, with lead nitrate. So here's my lead nitrate, here's my H2O. Gonna pour it in, mix it up. Now let's take a look. So now we got a bunch of nitrate ions, which has a negative charge. And you have a bunch of lead ions with a positive charge. And because the lead has a positive charge, it's going to be attracted to the O's with a negative charge in the H2O. And the nitrate has a negative charge, it's going to be attracted to the H with a positive charge in the H2O. And the ions are going to continue to move around, creating conductivity within the solution. Now the reason that the lead nitrate breaks apart is because the strength of the bond between the H2O, or the strength of the force between the H2O and the lead nitrate is stronger than the force in the ionic bond between the nitrate and the lead. Thus, the 2 ions are separated and the ion dipole bond forms. Alright, now it's time to mix the solutions together. Let's take the lead nitrate and the potassium iodide and pour it into 1 container. Here. Potassium iodide, lead nitrate, and mix it up and see what we get. Now let's see if any precipitate was formed. But before we do that, let's remember that for every 2 moles of nitrate, we have 1 mole of lead, 1 mole of potassium, and 1 mole of iodide. Now these ratios are important to figuring out the limiting reactant, the amount of products made, and the amount of each substance left over after the reaction occurs.
This is what a balanced chemical equation for the reaction looks like.
So let's take a look and see what was formed. What do we have here? Well, we know that the red is lead. And we know that the white is iodide. So we have lead iodide. Lead iodide. Lead iodide. Some more lead iodide. Lots and lots of lead iodide. Lead iodide. Let's see, what else do we have? Oh, this is cool. We got some nitrate right here in the blue, which is potassium. So we have potassium nitrate. Interesting. We have potassium nitrate, more potassium nitrate, some more potassium nitrate, lots more potassium nitrate. Wow, all these ions bonded to form different molecules, like potassium nitrate and lead iodide. Wait, but what's this? Do we have leftover ions? What? Wait, so this is a nitrate that's not bonded to anything, it's just a nitrate ion. And another nitrate ion, and a lead ion. Why didn't these bond with the potassium iodide like the other ions did? Oh, that must mean that potassium iodide is a limiting reactant. Why? Because we ran out of potassium iodide before we ran out of the lead nitrate, meaning that there wasn't enough potassium iodide for the lead nitrate to react with and form a new substance. Interesting. So now let's find out if, 1, a precipitate formed, and 2, if a precipitate formed, what is the precipitate? Well, in the reaction, we know that a precipitate must have formed because we see a yellow substance suspended in the liquid. So now we got to find out what that precipitate is. We have 3 options. Is it one of the original solutions, the lead nitrate, that's still in the ion form? Is it the lead iodide? Or is it the potassium nitrate? Let's start with our original solution. To start, we know that anything in solution form is clear. And since we have a yellow substance, we know that this solution couldn't have been our precipitate. Also, it contains nitrate, and nitrate always dissolves. So we can check this one off the list. Next, we got the potassium nitrate. Now, again, we also know that nitrate always dissolves. So we can check this one off our list too. So what does that leave us with? It leaves us with the lead iodide. And since the yellow precipitate did form, and these two couldn't have been the precipitate, we know that lead iodide must be our mystery yellow